Welcome to the last video for Algebra 1 for this current school year term of ending in 2014. So you can celebrate you've made it this far. The last topic that we're going to be covering this year is called literal equations. We've been working with rational equations where you have variables in the denominator. We're going to work with literal equations now where you have multiple different variables. You're solving for one variable in terms of another variable, and we're going to see that as long as you remember that these variables are simply factors and you can manipulate them using multiplication, division, subtraction, addition, just regular mathematical operations, you'll see that it's not quite as intimidating as it might seem perhaps at first. But I've got one last lame joke for you, and it says, what do you call 3 feet of trash? Today, for the first time, I found some kid math jokes out there. So what do you call 3 feet of trash? You call it a junkyard. 3 feet is a yard. So 3 feet of trash is a junkyard. So let's dive right into this. Actually, let me pray. Father, I thank you so much that you have been with us this year, that you have blessed me with the opportunity to go through this material with a wide number of people. I ask, Father, that you would help everyone who's watched these videos or been in a class of mine to have come away knowing more about Algebra 1 than they did when they began these videos. Father, I ask that you would go with us, that you would give us ears to hear you and willing hearts to follow you. In Jesus' name, amen. Okay, page 535 if you're using this text. Algebra 1 for Christian Schools, 2nd edition, published by Bob Jones University Press. Example 1 says, solve F is equal to WH over L. Solve for H. So when we have letters bumped up against one another like this, these are all individual variables. This is not, I think in English they call it a diphthong, 2 letters that make a sound together. But we have F is equal to W times H divided by L. Okay, and we want to solve for H. So it means we're going to have H on one side of the equation only, and all of the other variables are going to be on the other side. Now this is a rational equation because we're solving it. It has an equal sign, and it's rational because we have variable in the denominator. What we've been learning is that the way you eliminate these denominators, you're going to multiply both sides of the equation by the common denominator. This is easy here, there's only one denominator, so we're going to multiply both sides of this equation by L. And after you multiply both sides of the equation by a variable, you're going to cancel common factors. No common factors here. I tend to put letters in alphabetical order, and that's the standard convention. So L times F is going to be FL is equal to, as I just said, I'm going to make it alphabetical. I'm going to do the WH. Oh, I think that's funny. Is equal to WH. Why is it only equal to WH? Because we have this common factor of L that we can cancel. And clearly, this convention of putting things in alphabetical order doesn't always hold true. It holds true maybe perhaps a lot more frequently if you have like ABC. You're going to see ABC more frequently than BAC. Okay? Doesn't matter because multiplication is commutative. Now, we have no more denominators. We want to isolate H. We want to solve for H. So what has happened to H? It's been multiplied by W. We divide both sides of this equation by W. You now have a common factor of W that cancels, and you see that H is equal to F times L over W. That's all that's involved in solving this type of an equation. In the book it says LF. Is there a difference? I said FL. No. Multiplication is commutative. And I think that you probably followed this exactly. Let me change this example just a little bit and say that F is equal to 2H is equal to WH over, sometimes when I think on the fly it works well and sometimes it doesn't work so well, is equal to 2H over L. It's the only change that I've made to this problem. W is now a numerical factor. We want to multiply both sides of this equation by the common denominator, so you end up with FL is equal to 2H. Because what we did, we had that common factor of L that canceled. Now if we wanted to isolate H, here you would just divide both sides of this equation by 2, wouldn't you? And you would have that H is equal to F times L divided by 2. And I wanted to show you this just to jog your memory and say, oh, it might look strange to me to have WH, W times H, and have Miss Betsy be saying, well, just divide both sides of the equation by W. It's the same principle right here. This is what you're used to doing. If you have a numerical coefficient, 2 times H, you automatically, every single one of you, probably every single one of you watching this video, know to divide both sides of this equation by 2. It's the same principle here. We want to isolate H. It's multiplied by W, so you just divide both sides of that equation by W. So we've now solved this literal equation. We have H in terms of all of these other variables. All right, let's go ahead and move now to our next example. And this one is pulling way back to chapter 4 again, where we were clearing equations of fractions and clearing equations of decimals. And we didn't do much in the way throughout the year of clearing equations of decimals, so it's going to take maybe just a little bit of a moment to jog your memory, but same exact principle. Example 2 says solve D is equal to 0.07 V squared for V. And we have two things that are going to be issues for us to work with here. First, we've got this decimal, and then we have a square. We don't care about V squared, we want to know just about V itself. But the very first thing is, what do we do about clearing an equation of decimals? You're going to have to multiply both sides of that equation by the correct power of 10. What is 0.07? That's 7 hundredths, isn't it? 7 times 100th. You're going to multiply both sides of this equation by 100, because if you put it in fractional form, you have factors in common of 100 that cancel, or if you multiply this, move your decimal point 2 units, 0.07 times 10 to the second, or 0.07 times 100 gives us 7. So if you don't remember how to do this, or if my words right now made no sense to you, make sure that you look at page 536 and step through their example, or go back to chapter 4 where they're clearing equations of decimals. So when we multiply both sides of this equation now by 100, we have 100 times D is equal to 0.07 v squared times 100. What are we going to have now? We have 100d is equal to 7v squared. Okay? Let me check, make sure I'm getting this correct. Okay, what are we solving for? We're solving for v, and you're going to get some real algebra going on here, so get your minds totally focused in here. First, I need to divide both sides of this equation by 7. And I have 100d divided by 7 is equal to v squared. How do you solve an equation when you have the variable that has been squared? Well, you have to take the square root of both sides of that equation, don't you, to get v. And it's always going to be equal to plus or minus that square root. Square root of v squared is equal to plus or minus the square root of 100d over 7. Okay? Now this is really looking pretty messy. What do we remember? My words would say the square root of a quotient is the same as the quotient of the square roots. These two expressions here are equivalent, okay? I keep putting my marker on the wrong side. What are we going to end up with now is equal to v. The square root of 100 is 10, so you have 10, plus or minus rather, plus or minus 10 times the square root of d, which is not a 9, 10 times the square root of d, divided by the square root of 7 is equal to v. Is that our final answer? Why or why not? Okay, this is one of the hard problems you're going to have to work with, so hang with me here. You have to rationalize the denominator. Remember that term? You cannot have a radical sign in the denominator, so we have to multiply both sides, both the numerator and the denominator, by the square root of 7. Remember, and we don't multiply that on the other side because it's not necessary. It is of no value. This just is, we're multiplying by 1. If we multiplied v times the square root of 7 over the square root of 7, we'd still have v because we're just multiplying by an expression that is equivalent to 1. Now, what do I have? I have 10 times the square root of d times the square root of 7. Just like the square root of a quotient is the same as the quotient of the square roots, you have that same thing going on with multiplication. Square root of a product let me write it. Square root of a product, I can't do this. I was trying to give you a real life example. But if you had the square root of x times y, that's the same as the square root of x times the square root of y. What this says is the square root of a product is the same as the product of the square roots, which lets us put, since we have d times 7, we can combine those under one radical sign. I'm hopeful that this extra time I'm taking here really isn't necessary, that you understood exactly what's going on, but you would have plus or minus 10 times the square root of 7d, all of that over 7, and that's equal to v. And this is what your solution is. There are no perfect squares underneath the radical sign. there are no radical symbols in the denominator, and there are no common factors that you can reduce. So let's verify. Plus or minus 10 times the square root of 7d over 7. You wouldn't put the square root of d7 because mathematical syntax says put the numerical coefficient first. Okay, step back from this. Make sure that this makes sense to you, okay? All right, now you will enjoy seeing example number 3 now because I think it's easier than example number 2. Hang in there, guys. We are so close to being finished. I know you can finish strongly. All right, example 3 says solve 3a plus b times x equals 4x over 5 for x. Don't give up. How in the world are we going to solve for x? We've got a rational expression, rational equation going on here. We want to clear the equation of fractions. What's our common denominator? It's a 5. So we multiply both sides of this equation by 5. 5 times 3a plus bx is equal to 5 times 4x over 5. Cancel whatever common factors there are and distribute. So we have 15a plus 5bx is equal to 15a, let me see, (15a plus 5bx is equal to, we've canceled our 5's, is equal to 4x. Now, what are we going to do? Am I going to cancel out a common factor of 5 here? No. Keep in mind what it is that you're trying to solve for. We're trying to solve for x. We've got an a here, a b and an x, and an x. The only terms we want on the left-hand side of this equation are the ones that have an x in it. So we subtract a 4x from both sides. We subtract a 15a from both sides. So we have 5bx minus 4x is equal to negative 15a plus 4x. Everyone see what I did there? You make sure that you're good with that while I verify that I'm okay with what I did. All right? Because I'm trying to solve for x. But I don't have common terms here, do I? These are not common terms. I can't combine them because I've got a bx, which is distinctly different than an x. What did I do over here? Forgot to remove my 4x because I subtracted a 4x from both sides of that equation. How are we going to get that x all by itself? Exactly. You're going to factor out the x. So you have x times 5b minus 4 is equal to a negative 15a. Make sense? All I did was factor out an x. Now, even though this looks long, it's really just like saying 2 times x, isn't it? The first factor is x. The second factor would be like saying 2. We don't care what 5b minus 4 is. We're solving for x. So we're going to divide both sides of this equation by this factor here, which is 5b minus 4. You now have common factors that cancel, and you have x is equal to negative 15a over 5b minus 4. That's your solution. Pause the video, go back, work through it again. Look at it in your homework, make sure you can track and understand what's going on. One last example that I have to show you, it's there, example number 4. And I'm not going to do an extra one, but example number 4 says V is equal to E cubed for E. V is equal to E cubed. And they want us to find the value of E. E has been cubed. What's the inverse operation of finding of cubing something? That is taking the cube root of both sides of this equation. And it's not plus or minus because cube roots can be negative or positive. I mean, there's only one cube root. If you have a -8, the cube is a -2. If you have a +8, the cube is a +2. There are not 2 cube roots. It's equal to the cube root of E. So E is equal to the cube root of V. Really aren't cube root of V. There really are not a whole lot of steps involved in this. You have to simply have the understanding of what cube roots are. It was a little bit messy here with my writing. These both mean the same thing, cube root. That is the end of our lecture. Let me point you to one thing though, if you're in my co-op class. On page 536, they have an algorithm or a set of instructions or a procedure to follow for solving a literal equation. There are 5 steps to it. On the bottom of page 536, go ahead and make sure that you pay attention to this part of your text so that you understand the material. Come to class ready to enjoy our last day together. I'll see you on Friday.